Farmers and grazers know that monitoring the health of their livestock helps them identify and resolve issues more quickly, which saves time and resources. The same is true for monitoring the health of fields and pastures. Tools like the Pasture Condition Scoring or PCS procedures help both farmers and conservation professionals assess the management and general health of a pasture. Performing PCS multiple times during the year, especially during critical management periods, identifies management issues and also documents improvements. PCS is also useful for conservation planners using the Conservation Assessment Ranking Tool, or CART. This will be discussed later in the video. This training video provides an overview of the revised guidelines for pasture condition scoring, or PCS procedures. The tools provided in both the Guide to Pasture Condition Scoring and Pasture Condition Score Sheet offer a systematic way to assess pasture management and the resources protected. The PCS is based on research and development with years of review by forage and livestock scientists, as well as grazing professionals around the eastern United States. Let's begin by taking a look at the Pasture Condition Score Sheet. The top of the sheet contains sections for important background information. Pasture ID can be the field number or simply whatever name the producer uses to refer to the field. Livestock type is important because the species changes the type of desired plants needed in the pasture. You'll note whether the grazer has cattle, sheep, goats, horses, or possibly a combination. There's also a space to indicate soil type, ecological site description, or ESD, or forage suitability group, FSG, if needed and where available. ESD and FSG are being developed for Pennsylvania, which will outline another tool in matching suitable forage type and ecological conditions to the site-specific farm or area you're using for the inventory or monitoring. Finally, weather can have an impact on plant growth, so it's important to include the current season's precipitation level and temperature trends. The PCS involves a visual evaluation of 10 indicators used to rate the pasture. The indicators were defined after years of pasture study and will each be discussed in more depth throughout the video. Each indicator or factor has 5 possible ratings. These range from the lowest or poorest condition being a 1 to the highest or best condition being a 5. These identify the extent of any pasture challenges and help determine likely causes. Evaluate each of the indicators separately, and once complete, the individual responses can be combined to form an overall score. The first indicator is percent desirable plants. It's important to know and understand what species are desirable. This is based on the type of livestock currently on the pasture and what is desirable to this specific species. Each state has a desirable species list that is ideally organized by livestock type and dry weight, which is based on actual field measurements. Dry weight is used because it standardizes the process. It's the weight of the forage after all moisture is removed. There can be a huge difference in the amount of moisture present in forages. In the field, dry weight is estimated visually. It will take practice and training to imagine dry weight while looking at live plants in the field. Dry matter provides the basis for determining the amount of forage needed for the livestock. Different livestock species have varying forage preferences. Some plant species are not consumed or only consumed during certain stages of growth, in which case the species should fall into the intermediate or undesirable category and should not be called a desirable species. Desirable species are ones that are preferred and readily consumed by the livestock type. Certainly, people have differing opinions on what is desirable, but that preference should not be a forced preference. People will say, "My cows will eat anything," which may be true if they don't have a choice. Invasive species normally fall into the undesirable or intermediate category, but not always, depending on the type of livestock. For example, goats certainly will eat things that cattle won't.
This, as with all components of the PCS, is open to a certain level of subjectivity, but as long as the person doing the inventory is consistent in what they identify as desirable or intermediate, the method works.
Using the step point process is a way to provide excellent information for this indicator. This process will be demonstrated later in the video.
The next indicator is percent legume, which is measured by dry weight. Percent legume is important because the benefits tend to taper or flatten once 40% legume is reached. We also need to assess whether the legumes present cause bloat. A pasture with 50% bloating legumes could be a problem for some livestock types, such as dairy or equine, due to the bloating factor.
This type of field is scored lower than if it contained non-bloating legumes, but stands with greater than 40% non-bloating legumes are actually rare. Let's look at some examples. If a grazer has a stand with over 40% ladino clover, and that being a bloating legume would be scored a 2. This could happen frequently, even with combinations of red and white clovers, which are both bloating legumes. Now, if the percent legume, bloating or not, is under 41%, then it is scored as a 5 being 31 to 40% legumes. While not stated, if you happen to have all non-bloating legumes and they were over 40%, or the bloating legume component was not over 40%, but the total legume was, then you could still count it as a 5. The critical thing is making sure that the bloating legumes are not over 40%. Let's use these 3 photos to estimate percent legume. A visual estimation could indicate that the photo on the left is at 10%. The center photo may be 25 to 30%, and the photo on the right shows approximately 50%. If considered as if it had been clipped on site, dried, and weighed, the first one is actually only 6% by dry weight, the middle 15% by dry weight, and the sample on the right 27% by dry weight. These photos show white clover or ladino clover, which is a type of clover that is generally about 50% of the wet visual estimate. If using a visual estimate, reduce white clover dry weight estimates by half. This is only an issue with white clovers. Red clover tends to be higher, about 90% of that visual estimate. Alfalfa, if present, is almost 100% of the visual estimate. Step point is also valuable in estimating percent legume, and the result may be closer to that dry weight percentage if used. The next indicator is plant cover, which is really asking how good is the solar panel. Live plant cover is the amount of live stem and green leaves. Stands need to be dense with a high stem tiller count and serve as an excellent interceptor of sunlight, or in other words, act as a great solar panel. Is there adequate leaf area to intercept that sunlight? Will the bite an animal takes be of high-quality live forage, or does it include standing dead material? Management factors that influence standing dead material include frequency of grazing, length of the grazing period, stocking rates, density, and the length of the rest period. This can be more difficult to judge as the season moves into late fall and winter, but there will be some green color left in live dormant plants, even though photosynthesis has all but stopped.
Warm season grasses are an exception, as they go completely dormant in the winter.
Long deferments from grazing tend to be discounted due to more standard material present, especially over time. This indicator will also rate lower during winter, but remember it's only one indicator. The app Canopio is a useful tool for a phone or tablet that measures all green material or live green solar panel present. From the picture on the screen, Canopio actually indicates that there's 94.89% live green canopy. A windshield view would likely result in an underestimation of how much solar panel is actually present. Next is plant diversity. Pastures need plant diversity. It helps make a pasture become a more reliable supplier of forage throughout the growing season. The more functional groups that are present, the greater the diversity and resilience to changes in weather and long-term forage quality. At least 15% is needed to be considered and counted as a dominant species. A functional group can include several species, but also needs to make up at least 15% of the stand to be counted. We have 4 main functional groups. Those include cool season grasses, warm season grasses, legumes, and non-leguminous forbs. By quickly assessing the functional groups that are present, and also how many dominant species there are, particularly the ones that are greater than 15%, you can quickly score this indicator. Several minor species within the same functional group that add up to be at least 15% can also be counted for that functional group. This is actually fairly uncommon, but it can happen. It generally doesn't stay that way long because one of the dominant species often crowds out those minor species over time. Again, this information is also easily collected using step point. This example has a fairly high percentage of undesirable species, actually 52%. If desirable species are less than 50%, or in other words, undesirables are over 50%, then it's automatically a score of 1. In this example, there are 4 dominant desirable species that are over 15%, timothy and bluegrass, and the red clover and white clover. Also, there are 3 functional groups being represented, including cool season grasses, legumes, and forbs. The forbs are chicory, plantain, and dandelion, which add up to at least 15%, so we can count them as a functional group. Because of this, the pasture has 3 functional groups, 4 dominant desirable species present, and so it's rated as a 5. Residue is dead plant material in various stages of decay, and litter is the uppermost layer, including freshly fallen or slightly decomposed material. For this indicator, it should be thought to be primarily what is on the soil surface, not standing dead plant material, which is part of the live plant cover indicator. The old PCS indicator for residue was more about assessing standing residue and its impact on forage quality, especially for Northeast dairy operations. Looking carefully at the photo, you can very easily see bare soil. Because of this, we're going to rate this a 1. Again, this indicator is all about soil cover. What's important about plant residue and litter on the surface? It provides protective cover for the soil that helps to slow evaporation, keep soil cool, and is a potential carbon source for the soil and increases potential for improved rainwater infiltration. Remember, residue is plant material in various stages of decay. Litter is generally the uppermost layer of detached residue on the soil surface, not standing dead material. So when you're in the field, take time to pull back the canopy and look. Proper amount and frequency of grazing are critical in maintaining productive pastures. Close and frequent grazing causes loss of vigor. It reduces density of the desired species, reduces yield, and can promote erosion. It can also have an impact on bite size and intake. Differences in species, plant maturity, stocking rates, location, the distance to water and shade, and even mineral availability may cause uneven grazing to occur. These examples show 2 extremes, from overgrazing throughout with livestock refusing undesired plants, to a pasture that's grazed evenly throughout with no overgrazing. Note the differences in bite size and quality. Zone grazing occurs in one end of the pasture or when certain areas are heavily grazed and the rest is lightly grazed or even ungrazed. Zone grazing occurs on pastures with long walking distances from one end to the other, especially when shade, mineral feeding, or watering sites are a long distance from some parts of the field. When zone grazing is occurring along with some uneven grazing across a path, it's rated a 3. but rate the pasture a 4 if the pasture is uniformly grazed to, say, target stock grazing heights, but there's still some zone grazing occurring. Livestock concentration areas include but are not limited to winter feeding and loafing areas. Water quality degradation is a main focus here. Therefore, the distance to water is important, as well as the actual size of the concentrated area. And note that size is used instead of percentage. There are some real cases where the percentage gave the rating a higher score than the risk that was actually occurring. For example, a large pasture with many concentrated areas of bare ground received a rating the same as a small pasture of only one area because the percentage was the same. The pasture with more bare ground would receive the lower rating using this method. Consider the size of the concentrated area. Exactly what is 0.1 acres? It's approximately a 66 by 66 foot area. This is either visually estimated, stepped off, or even just measured. In the first field, the concentrated area is over 0.1 acres and is less than 100 feet from the water body. It could be rated a 1 because it has a higher probability of having water quality issues. In the second example, the concentrated area is less than 0.1 acre, but it is still less than 100 feet from the water body, so rated a 2. In the last example, the concentrated area is greater than 0.1 acres, but is over 100 feet from the water body, so that distance is helping to mitigate potential issues and is rated a 3. The first example has a concentrated area of less than 0.1 acres, and it is also over 100 feet from the water body. It is low risk and rated a 4. The next has no concentrated areas in the field, so it's rated a 5. The last example is a field of less than 1 acre, which seemed to be increasing in number. It may be a horse lot, a few goats, or perhaps even being used for a 4-H calf or a bull. Use the percentage of 10% instead of 0.1 acres for a field which is under an acre of size. Take the disturbed area and divide by the field acreage. In this case, it is less than 10% at 7.5%, but it's also under 100 feet to the stream, so we're going to rate it a 2. Let's now look at soil compaction and soil regenerative features. These indicators focus on the soil structure, plant roots, organic matter, and soil life. We want deep growing roots, good water holding capacity for plant productivity, plant health, and nutrient density. Healthy soil makes healthy plants and helps grow healthy animals. The compaction indicator should be looked at in the top 12 inches of soil. To know for sure whether or not there are compaction issues limiting plant growth, 2 holes should be dug. Yes, you will need to use a shovel.
Digging 2 holes is preferred but not required. It does provide the opportunity to compare fence line compaction with field compaction, specifically how structures impacted.
The first hole should be in a fence line where no compaction is evident, where animal hooves have not had an impact, yet they are still able to graze the grass that grows. The other hole should be dug inside the pasture, in the same soil type, and ideally in an area that you think may have a compaction issue. Then observe and compare in each hole the ease of getting the shovel into the soil, the rooting depth, the root morphology or direction of growth. They should be growing down through the soil profile, not horizontally, which is an indicator of compaction. The soil structure should look more like cottage cheese, not platy, especially if that platiness is in the top 12 inches. And that is another indicator of compaction. Also, observe any earthworm or insect presence or activity. For this indicator, choose the most adverse factor for deciding score based on roots and compaction being the primary indicators and considered first. And then use soil color and soil life as secondary indicators where relevant. Soil color and soil life shouldn't be the deciding factors, but are useful in discussions about soil health and as indicators for possible improvements. Soil regenerative features focus on the condition of plant roots and the abundance of soil life, both of which can improve important soil attributes like structure and organic matter. Soils with roots growing deep and downward have the potential to feed large and diverse populations of soil life. Contrasting color changes in the soil with darker soil in a more biologically active upper layer is usually a very positive indicator. Worms, worm tunnels, or other insect presence and activity are also good indicators. Again, choose the most adverse subfactor for deciding the score based on roots and compaction being the primary indicators and considered first, and then soil color and soil life as secondary indicators where appropriate. In this case, since there was a compaction issue, that subfactor dictates the score of this indicator, so it's going to be a 3. In simplest terms, plant vigor refers to the health of the plant. A loss of plant vigor can cause a loss of desirable species and plant cover. Plant recovery should be evaluated based on average growth rates for the plant community involved at a time in the season being rated. The more severe the grazing, like grazing below stock grazing heights, the longer recovery that's going to be required. Most severe grazing occurs when a pasture is overstocked. Pasture plants, when continually grazed, have little or no recovery. Color is a major indicator of plant vigor, and yellowing plants can indicate drought, insect damage, or prolonged heavy use. Pale green grass plants indicate low fertility or cool, wet, poor quality soils or poor growing conditions. Fields where nitrogen-starved grasses exist will be obvious, have dark green spots around dung or urine patches, and be pale in comparison to the rest of the pasture. The primary things to consider when rating plant vigor are color and rate of regrowth, especially following a grazing event, but also taking into consideration the grazing height of plants and the size and density of plants and productivity. This indicator is purposely placed as one of the last indicators. Earlier indicator information can be useful in helping to score plant vigor. In the first picture, color for desired species isn't too bad, but there was no recovery. In the second picture, there's good recovery and there's also good, healthy green forage color. The first pasture would be rated most likely a 1, the second pasture a 5. You see, color is a very good indicator of plant vigor. The erosion indicator is fairly well defined, but keep in mind that multiple types of erosion may be present in the same field. Circle all types of erosion that are present in this pasture. Both sheet and rill and the start of gully erosion are present. The most adverse type indicates the score. In this case, it's going to be a 1. Gullies are considered all types for this score sheet. It's time to add up the scores. The overall score gives us an idea of suggested management changes. A pasture rated with a high score is well managed with plant-animal productivity being sustained or even enhanced. By rating key indicators common to all pastures, pasture condition can be evaluated and the primary reasons for a low condition score can be identified. A low rating typically means that the pasture has one or more challenges. It may be poor plant growth, weedy species invasion, low forage quantity or quality, maybe a soil loss, increased runoff, or impaired water quality in or adjacent to the pasture. Step point was mentioned several times during this video. The step point method is highly recommended for the pasture condition score sheet because it answers 5 of the PCS indicators.
Using the step point method as a first step gives you a chance to look at the larger management unit or field while you walk the pastures prior to starting the PCS inventory.
It provides numbers, not just visual estimates, and so gives you more confidence to choose a score. It also gives an accurate assessment of what the dominant forage species really are, and by using a shovel for compaction in acreage with livestock concentration areas, you have confident numbers for 2 other PCS indicators. This makes the remaining 3 indicators less subjective and provides a basis to more confidently score them. To use the step point method of data collection, use your state step-in data collection sheet and take the same paced number of steps each time. This could be 3 steps for a smaller field or 10 steps each for a larger field. The goal is to collect a representative sample. The step point method uses the same foot for each reference point. You step, then look at the point of your shoe and record what is present, including plant residue and any bare soil. Step again, collect more data.
As demonstrated here, you may use your foot to pull forage aside to assess residue if needed.
Step, collect data. Continue this process until you have 100 points, each representing 1%. This data can then be used to help complete some of the PCS indicators. Pastures should be rated at least annually. Rating these pastures can help set and track trends on pasture condition. Those indicators may rank low initially, but as management improves, the improvements will be recognized on the Pasture Condition Score sheet. These scores and the summaries should be addressed and discussed with the landowner in the field if possible.
Those working for the NRCS should note that this assessment is usually needed for the Conservation Assessment Ranking Tool, or CART.
The list of PCS indicators that are presently being used in CART include percent desirable plants, live plant cover, plant diversity, plant residue and litter as soil cover, soil compaction and soil regenerative features, plant vigor, and erosion.
Please refer to the Revised Guide to Pasture Condition Scoring, published in January 2020, for additional details, and contact your state NRCS grazing specialist or soil conservationist with questions. Thank you.